Hi everyone, in this video we're going to go over an example that's going to actually get through several topics and as far as applying our concepts of the derivative that we just learned in calculus to a business scenario. So we're going to talk about things like cost, marginal cost, which we'll find is just the derivative of the cost function. We'll talk about demand and revenue and ways to model those, as well as marginal revenue, which you won't be surprised. Marginal revenue is just the derivative of revenue. And then we'll also talk about profit, what that means, and also marginal profit. And marginal profit is going to be the derivative of profit, just like with the other marginal values. And so without further ado, let's get going. Our example. And this is going to be a long example. We're going to stick with the whole video. But our example says, Amanda wants to start her own business, making and selling scented candles. It costs money to produce candles because she has to purchase wax, jars, scented oils, wicks, labels, ink, lids, and burlap pouches. Plus, she also needs a heat source to warm up the wax so that she can mix the scented oil into the candle wax. And whether you're getting your heat from gas or electricity, heat costs money either way. And she needs some probably like hot plate or something to warm this up on. So the total cost of production, we're going to represent cost with the capital C. It's going to be a function of the number of candles she produces in a batch. And so lowercase n is going to be the number of candles produced. So cost is a function of the number of candles produced. And it should make sense that the more candles you make, the more it costs total. Question 1 says, if Amanda plans to produce 20 candles, what is the total cost of production? And so this is as easy as evaluating our cost function at the point n is equal to 20. And so I'll write 90 plus 2 times 20 plus 10 times 20 to the power 0.7. And for our purposes today, I need a calculator. So hopefully everyone can see this calculator when I bring it over. And what I'm going to punch in here is 90 plus 2 times 20 plus 10 times 20 raised to the power, on your calculator, that's this little caret symbol, 0.7. So my calculator tells me this is going to be $211, and we'll just round up to the nearest dollar. So rounding, my cost of making 20 candles is going to be $211. Excellent. So question 2 says, if Amanda plans to produce 20 candles, what's the average cost per candle? And so to take average cost, what we're going to do is take the cost and then divide by the number of candles produced. And this is going to give us the average cost. And we're going to denote average cost the way our textbook does. And our textbook denotes average cost by just putting a bar over the C. So this over bar means average whenever you're working problems from our textbook. So the average cost is going to be the cost divided by n, and so we had a cost of $211, and we had 20 candles. So, taking half of 211, that's going to be 105.5. And then dividing by 10 means I move the decimal, so this is going to be $10.55 per candle. So the cost of production is pretty high. I mean, $10.55 per candle is not cheap. Question 3 says that if Amanda plans to produce 20 candles, what would be the cost to produce one more candle, right? So she's already planning on a batch of 20 candles. What if she extends the batch to 21 candles? How much more is it going to cost? And my hint for you is that this question, whenever we ask what's the cost to produce one more, we're saying, this is the marginal cost. What we mean when we use the word marginal is what's the cost to produce one more. It's the cost on the margin. And really, that's just the definition. I'm trying to think of a way to extend this to paper, because we call this space between the edge of the paper and where the text starts. We call this the margin. And so somehow this helps me remember what marginal cost means, because it's like, if you're producing paper and you're planning on producing a paper that's like 8.5 inches wide, for example, and then you think, what's the cost of extending the paper to be just a little bit wider? You're talking about maybe adding a little bit to the margin. And so that helps me, but also if it doesn't help you, you can just ignore that. But the marginal cost is going to be the derivative of the cost function. So for marginal cost, we use the symbol C prime to represent the derivative of the cost function. And so since this is our cost function, and we learned some rules for taking derivatives, I know the derivative of a constant, like that 90 term, is 0. And then for 2 times n, that term is like 2 times n to the 1 power. And so remembering our homogeneity rule, I can actually just leave that 2 alone when I take the derivative with respect to n. And I'll just leave that 2 there, and then n to the 1 power. My power rule tells me I'm going to bring down that exponent in front, so I have 1 times n, and then I reduce the exponent by 1, according to my power rule. So I have 2 times 1 times n to the 0 power. But n to the 0 power is just 1, so I have 2 times 1 times 1. And so this derivative is 2 for that second term. And then for my last term, where I have 10 times n to the 0.7 power, let's think about that, just by itself. And I can consider each of these terms separately because of our derivative additivity rule. So just to remind you of the names of these rules, I guess, from a previous lesson on derivatives. But if I try to take this derivative of this term by itself, then taking the derivative with respect to n, well, I can leave the 10 alone, because that's our homogeneity rule at work. And then for n to the 0.7 power, my power rule tells me that this will be 0.7 times n to the power 0.7 minus 1, which is negative 0.3. So I multiply 0.7 times 10, and that becomes 7 times n to the negative 0.3. And remember, what it means to be a negative exponent is that you can put it in the denominator. So this would be the same thing as 7 divided by n to the 0.3 power. So this would be plus 7, and I'm just going to leave it as 7 times n to the negative 0.3. Because honestly, I kind of like negative exponents rather than putting something in a denominator. And of course, adding 0 doesn't do anything, so we can actually just forget about that 0 plus part. And this would be the formula for marginal cost. So for my hint, where it asks what is the formula for marginal cost, that's our formula. And so now, if we were planning to produce 20 candles, the marginal cost for producing 20 candles would be 2 plus 7 times 20 to the power negative 0.3. And so I want you to notice that this marginal cost, it's always going to be at least 2, because I've got that constant 2 in there. But it's also going to include a term that decreases as n increases. So when n becomes a larger number, that n to the negative 0.3 power, that's actually going to get smaller over time. Although it's never going to be a negative term. that term's not going to, well, actually, hold on. Let me think about this. Right, so this term, 7 times n to the negative 0.2 power. The value of this term right here will never be negative, but it does get smaller over time. And eventually this term is going to approach 0. So if you were going to create like infinitely many candles, your marginal cost would just be 2. Okay. But that's enough. We actually have a formula now that can tell us our marginal cost when n is equal to 20. That's right here. All I need to do is put that in the calculator. So I need 2 plus 7 times 20 to the power negative 0.3. Okay. And that looks like my marginal cost is $4.85. So I know it's got pretty hectic here, so I'll just put my answer in red. My answer was $4.85. So the question is kind of interesting if you think about question 2 with question 3. You know, producing 20 candles means that your average cost per candle would be $10.55. But if you were to produce one extra candle, the cost of producing one extra candle is actually only $4.85. So this, again, illustrates that the more candles you produce, the lower the cost per candle is going to be. Okay. And then we have the same 3 questions for question 4, 5, and 6, but this time we're plugging in n is equal to 500. And so I'll, again, work this very quickly so we can see what's going on. As our number of candles becomes larger and larger. Switch to like purple. And so just like question 1, in question 4, what we're going to do is we're just going to plug in 500 into our cost function. And then just like in question 2, for question 5, when we ask about the average cost, my average cost is just the cost divided by the number of candles produced. So this time I'm going to be dividing the cost by 500 candles. And then in question 6, just like in question 3, I'm going to use my marginal cost to figure out how much does it cost to produce one more candle. And I'll be evaluating that marginal cost function at 500. So for question 4, I've got my original cost function of 90 plus 2 times n, which n is now 500, plus 10 times n, 500, to the power of 0.7. So I'm going to need a calculator for that. So 90 plus 2 times 500 plus 10 times 500 to the power 0.7. So my total cost for question 4, I'm going to round it to the nearest dollar and just say that it's $1,865. So if I want to produce 500 candles, it'll cost me just shy of $2,000 for the total cost. And if I want to find the average cost, I just take that total cost and divide by the number of candles produced. And taking that number divided by 500 is going to give me 3.73. Yeah, so if I have a really large batch, the price per candle gets actually pretty small. $0.73 per candle doesn't sound that bad. And in question 6, taking the marginal formula, so up here is our marginal cost formula. That's 2 plus 7 times n is 500 now, to the power negative 0.3. I have 2 plus 7 times 500 to the power negative 0.3. This tells me that the cost to produce one additional candle is going to be $3.08. So again, your marginal cost, most of the time, for situations like this, whenever you have economies of scale working in your favor, where you produce more and more, you can probably buy your raw materials cheaper. And maybe if you had to buy some sort of fixed equipment, like a hot plate to melt your candle wax, the more candles you produce, the more that initial cost of the hot plate is spread out over your candles. Of course, making more candles is always cheaper per candle than making fewer candles. Okay, so continuing with our scenario, it says Amanda needs to estimate the consumer demand for her product. In other words, for a given retail price per candle, P is the retail price that she's selling the candles for, how many candles would she sell? So suppose she takes her candles to like a farmer's market in town, and let's say that there's 2,000 people at the farmer's market, and depending on her price, more or less of those people might buy her candles, right? So if she's giving the candles away for free, maybe all 2,000 people are willing to pick up a candle. I mean, it's free. Why wouldn't you grab one of these candles? But if the price gets too high, like if she decides to price her candle above like something like $20 per candle, maybe no one's interested, because who would want to pay like $25 for a candle, right? So this is the equation that's going to describe our demand, which is how many candles will she sell to her consumer audience as a function of price. So N is what we would call the demand, and P is our price. This is our demand function. Question 7 says, if Amanda sets the price at $5 per candle, how many candles does she expect to sell? And so this is our price. So you write the function N is equal to 2,000 minus 100 times $5. And so 100 times 5 is just 500. So we've got 2,000 minus 500. And 2,000 minus 500 is 1,500. So if she sets the price at just $5 per candle, she could sell 1,500 candles, according to this model of our consumer demand. Question 8 says, if Amanda sets the price at $10 per candle, how many candles does she expect to sell? And so here we go. We've got $10 plugged in for the price now. And so this is going to be 2,000 minus 1,000. And so we're talking about N is equal to 1,000 candles that she expects to sell. So as the price increases, she's selling fewer and fewer candles. It says if Amanda sets the price at $20 per candle, what happens? And so if we set the price at 20, we're talking about 2,000 minus 2,000. And so she's going to sell 0 candles if she raises the price to $20, because that's just too much for the price per candle. So no one wants to buy an expensive candle. Question 10 says, rewrite the demand equation above so that price is a function of candles sold. And the demand function we were given was N is equal to 2,000 minus 100 times P. But now I want to solve explicitly for price. And so to do this, I'll subtract 2,000 from both sides, I think. Or maybe instead I'll just I'll add 100p to both sides. That sounds better. So on the left side I have N plus 100p, and on the right side I have 2,000 because those cancel. And then again, trying to solve for p, I'll subtract n from both sides. So on the left I get 100p, and on the right I get 2,000 minus n. And then again, solving for p, I will divide both sides by 100, and what I will get is that P is equal to 2,000 divided by 100, that sounds like 20, minus 1/100th times N. So this is the price that I should set for my candles if I want to sell N candles. So the consumer demand function is helpful in 2 ways, depending on what you're trying to predict. So the question 11, of course, uses this new formulation of our demand function, and it asks if Amanda wants to sell 500 candles, at what price should she list her candles? And so we'll use this new equation that we found up here because it gives me price as a function of the number of candles I want to sell. And so if I want to sell 500 candles, because maybe I don't have any time to make any more candles, then we have 20 minus 1/100th of 500 is going to be 5. And so this is saying we could set our price for $15, and at that price, exactly 500 customers would be interested in purchasing a candle. Okay, now continuing, but introducing new concepts for the same example. We have revenue. So revenue is the total amount of money brought in by a business. In the case of Amanda's candle business, our revenue, which we're going to use the capital R to represent revenue, revenue is going to be a function of the number of candles sold. And this is specifically the number of candles sold times the price of each candle. And this is going to work because the total money brought in is going to be P dollars for every candle sold when she sells N candles. So the number of candles sold times the price of each candle, that's how much money people are going to be handing her at the farmer's market. And so we have a expression that tells us, what should be the price of the candle if I want to sell N candles. And I kind of simplified this a little bit, but you could write this as, cancel the hundreds. Left side becomes P equals 2,000 minus N over 100, and you could just leave it like that. And so that's what I have going on here. I'm letting P become this expression, which is 2,000 minus N divided by 100. Now, because I made that substitution and I wrote my price as a function of the number of candles sold, my revenue is now just a function of N, which is exactly how I want it. I want revenue to be a function of the number of candles sold. So that I can answer question 12, where it asks, when Amanda plans to sell 20 candles, what is the total revenue? Well, we're asking, what's this revenue function? When I plug in 20 for N. And this will be, of course, N, which is 20 times 2,000 minus 20 divided by 100. So this is going to be 20 divided by 100. I'm just going to move that denominator over here, times 2,000 minus 20. Well, 2,000 minus 20 is going to be 1980, which is going to be, I'll just take a 0 off of each of those. And so 20 over 100 is the same thing as 2 over 10, and 2 over 10 is the same thing as 1/5. So this is 1/5 of 1980, or you could write that as 1980 over 5, and I actually don't really know this, so let me do 1980 divided by 5, and this is 396. Cool. So very good. If we plan to make and sell 20 candles, my total revenue, capital R, is going to be $396. That's the amount of money we brought in because we sold 20 candles at some price, and you can figure out what the price was if we sell 20 candles. But you'll have to use the price function. So it'd be 2,000 minus N divided by 100. And 2,000 minus N was 1980 divided by 100. The price we're selling at is $19.8 per candle. So if I sell 20 candles at $19.8 per candle, that nets me $396 in total revenue. Okay, moving on to question 13. If Amanda plans to sell 20 candles, what's the average revenue per candle? So the average revenue, we're going to represent that with this symbol, capital R with a bar above it, just like we used for average cost. We're going to put a little bar to mean average. And then this is going to be a similar formula. I just take the total revenue and divide by the number of candles sold. So my total revenue was 396, and I'm going to divide by 20 candles because I sold 20 of them. And so this is going to be 39.6 divided by 2, which will then be, it's like a little bit less than 20, right? In fact, I think it's going to be 19.8. And maybe this comes as no surprise to you that this should be 19.8. And why is that no surprise? That our average revenue per candle is 19.8. Well, that was actually our price per candle. So let me just show you something right here. If I go all the way back to first principles, the fact that our revenue for this business is just number of candles sold times price. So if I ask about average revenue, that was revenue over the number sold. But if revenue is just N times P, and average revenue is dividing that revenue by N, well then these N's cancel, and the average revenue for this business, since we're just selling candles, the average revenue per candle is just going to be equal to the price. So hopefully that makes sense. And then for question 14, it says if Amanda plans to sell 20 candles, what is the revenue for selling one more candle? So whenever just like we talked about price, when we ask about selling one more, we're talking about making candles on the margin. So we're asking what is the marginal revenue, and marginal revenue is going to be the derivative of revenue. So taking the derivative of revenue with respect to the number of candles. Right, let's go back and look at our revenue function, which was N times 2,000 minus N over 100. Well, let me distribute this N inside here. And I'm also going to sort of factor out this 1 over 100. So that I'm going to get 1 over 100 times 2,000 times N minus N squared. And if that's not completely obvious to you right now, work through the algebra on your own to make sure you understand how we went from this step to that step. That would be important to be a good algebra check, to know your algebra skills. I'm sure I'm going to expect you to do this on an upcoming quiz and exam. So here we go. This is our formula for the marginal revenue. No. Sorry. This is still revenue. So I shouldn't put a prime there. This is our formula for just revenue. I've just been algebraically manipulating the revenue. If I actually want to take the derivative now, which is r prime of n, then I'm going to just basically say, well, this term right here, well, let me point out the factor first. This 1 out of 100 factor, I'm just going to keep that. And why do I just get to keep constant multiples? Well, we call that derivative homogeneity. So we just ignore constant multiples when we take the derivative. Then this term right here where it says 2,000 times n, well, the power rule for n to the 1 power tells me that that should become 1 times n to the 0 power. N to the 0 power is just 1, so that's just 1 when I take the derivative. And so if I have 2,000 times n, this is going to be 2,000 times 1. And so, sorry, this chain looks a little bit sloppy because I'm just ignoring the 2,000 until the end. But this derivative of 2,000 times n is just going to be the number 2,000. Okay. Then I also have to deal with this term, which is n squared. And taking the derivative with respect to n, like we did here, taking the derivative, is going to be 2 times n to the 1 power, which is just 2 times n. Again, using what we call the power rule. And we learned that in a previous video, so go back if you need to review that. So taking the derivative of n squared is going to be 2n. And now maybe if you want to distribute the 1 over 100 into this, I'm running out of space here. Maybe I'll do some erasing so I can make room for one more step. We can write r prime of n is equal to 2,000 divided by 100 is just 20 minus, and then 2 over 100 times n. And simplifying a fraction, 2 divided by 100 is just 1 over 50. So this is our formula for marginal revenue. And our question was asking what was the marginal revenue when n is equal to 20 candles. So let's calculate r prime of 20. So it'd be 20 minus 20 divided by 50. And just put this in the calculator real quick. So 20 minus 2/5. That looks like it's going to be 19.6. So here's the question. Why is our average revenue per candle just equal to the price? But my marginal revenue for selling one more candle was not equal to the price. That's because if you actually want to sell one more candle, you would need to increase the demand for candles by one more candle. But increasing the demand, you'll remember, means decreasing the price. We have this relationship between price and demand, right? So this is going to be a better way to look at it. If I want to increase N, that means I would have to decrease P. So if I want to increase the number of candles sold, I have to actually decrease the price per candle. So that's why actually the marginal revenue of selling one more candle, when you consider that you have to motivate one more customer to buy a candle, means you have to lower the price of the candles. That's why the marginal revenue is actually lower than the price of candles. So it's not quite the same as average revenue. All right, question 15, it says if Amanda plans to sell N is equal to 500 candles, what is the total revenue? And so you'll notice question 15, 16, and 17 look a lot like the previous questions, but I just changed to selling 500 candles so we can get a different feel for the large batch. And again, we're doing total revenue, we're doing average revenue, and we're doing the revenue for selling one more. And so again, we're talking about total revenue, which is capital R, average revenue, which is R bar, and then the marginal revenue, which is R prime. And so our total revenue, that function was just it's a little bit difficult for me to remember. N times 2,000 minus N over 100. N times 2,000 minus N over 100. R bar, the average revenue, is just the revenue over N. And that, again, would just be the price of the candle. You remember our discussion about that a moment ago. And then my marginal revenue function we found just a moment ago, which is up here. Marginal formula, which is just the derivative, is 20 minus 1 out of 50 times N. So if N is 500, this is 500 times 2,000 minus 500 over 100. So this is going to be 500 times 1,500 over 100 is just 15. And 500 times 15 would be 75 for 5 times 15. And I add 2 zeros. So actually, if I sell 500 candles, my total revenue is going to be $7,500. Nice. This average revenue would just be the price. So that would be 1,500 over 100, which is just 15. So if I plan to sell 500 candles, my price would be $15, and the price would be the average revenue per candle. And the marginal revenue for selling one more candle after 500 candles it should be lower than the average, but just by a little bit. And so we've got 20 minus 500 over 50. So that would be 20 minus 500 over 50 would be 50 over 5, which would be 10. So the marginal revenue should be $10. Yeah, so if I want to motivate a customer to buy one more candle, that means I have to lower the price for a little bit, just a little bit. And lowering the price is not just for that last candle, but we're assuming that the price is constant throughout the entire farmer's market. And so we're talking about lowering the price for all 501 candles. So yeah, you get the revenue from the one additional candle that you sell, but you have to lower the price just a little bit for all 501 candles. And so the net effect is going to be an additional $10 of revenue for selling one more candle. And so this is the marginal revenue at n is equal to 500. Okay, and this is our last page. So the video is nearing an end. I know this is a long example, but I wanted to put it all in one video since it is all one example. And we finally got into profit. So we talk about profit as being the difference between revenue and costs. And we always have revenue be positive, and we always subtract out the costs. So if our revenue is more than cost, that means we made a positive profit. And if our costs are more than our revenue, then when you go to calculate profit, it should show you a negative profit. And a lot of times in business, you call negative profit a loss. But anyways, this is our profit formula. Since revenue and cost are both functions of n, which we've seen before, then that means the number n is the number of candles that we produced and sold. Then profit also has to be a function of the number of candles produced. So profit is a function of n because both revenue and cost are now just functions of n. And so if I plug in the function for the revenue that we've been using, and if I plug in the function for the cost, the total cost we've been using, which is C of n, you can rewind the video if you need to see how we arrived at that formula. Let's try to answer question 18, which says, if Amanda plans to produce and sell 20 candles, what's the total profit? So total profit for 20 candles means I'm trying to evaluate my profit function when n is 20. And let's see if we can actually simplify this profit function so that we don't have to quite do as much work for each of these questions. So over here, I'm going to have 2,000 divided by 100 times n. So that's going to be 20n. And then minus n times n over 100 is going to be minus n squared over 100. Then we have minus 90 when I distribute that minus sign inside the parentheses, minus 2n when I distribute the minus sign, and then minus 10 times n to the power 0.7 when I distribute the minus sign again. And I can collect like terms here, because I have 20n minus 2n, that's just 18n. This is the only term where I have n squared, so I leave the minus n squared over 100. This is the only constant I have, and this is the only power of n where the power is 0.7. And so this is going to be my better or easier to use function for profit, actually. So this is also profit as a function of n. And actually, hold on. I see one more thing. Oh, never mind, I don't. I just accidentally erased a exponent 2. So that's supposed to be n squared right there. Okay. So what's the profit for when n is equal to 20? This would be 18 times 20 minus 20 squared over 100 minus 90 minus 10 times 20 to the power 0.7. So let's just put that in the calculator just as it is. So 18 times 20 minus 20 squared divided by 100 minus 90 minus 10 times 20 to the power 0.7. So my calculator tells me that my total profit is going to be $184.58. For selling 20 candles, my profit is $184.58. So again, this is just revenue minus cost. So we can look at previous pages when we were talking about revenue for 20 candles. My revenue was $396. So the revenue was more than the profit because I had to subtract my cost, which was $211 for producing 20 candles. Okay, now we're asking about average profit. And so average profit, we'll use P bar to represent the average. And so this is just going to be total profit divided by number of candles. And so this is 184.58 divided by the number of candles, which is 20. And so doing this, take that number we got previously, divide by 20, and we get 9.23. So my average profit per candle was $9.23. In question 20, if Amanda plans to produce and sell 20 candles, what's the profit for selling one more candle? In other words, what is the marginal profit? And you guys know by now, marginal is talking about the derivative of the profit function with respect to n. And this is going to be maybe a little bit difficult to find because what I've got to do is I have to go back to my profit function and this time apply my power rule to all of those terms. Or maybe, if you're really astute, you say, well, I remember the additivity rule of derivatives, which means that if profit is just revenue minus cost, and I ask about the derivative of profit, well, that would just be the derivative of revenue minus the derivative of costs. Yeah, this is what we call the additivity rule of derivatives. Is if you're taking a difference, if you're taking the derivative of a difference of two functions, you can actually just take the difference of the derivatives of each function. And so it's called additivity, and you can go back to a previous lecture and see where we were talking about that. I think the previous video is called Derivative Basics, if you need a refresher. Okay, but knowing this, and knowing that we did have an r prime and a c prime function, let's go back and figure out what was r prime. Well, r prime was this. It was 20 minus n over 50. That's what we found, 20 minus n over 50. And c prime, let's go back and find out what we found for the marginal cost. C prime was this, 2 plus 7 times n to the negative 0.3. 2 plus 7 times n to the negative 0.3. Plus 7 times n to the negative 0.3. So I distribute that minus sign inside these parentheses because I want to subtract the whole cost and not accidentally add any terms from the cost function. I get this. And so 20 minus 2 is 18. So I'm just simplifying a little bit here. And then this looks good. So my marginal profit is going to be 18 minus n over 50 minus 7 times n to the power negative 0.3. And as a challenge for you guys, just try to use your power rule on each of these terms and see if you can get the same derivative doing this. So maybe pause the video and see if you can see how we achieved each of these. Okay. Assuming you've done that, let's answer question 20. So actually coming up with the answer for question 20, which is whenever we sell 20 candles, what would be the profit for selling one more candle? In other words, what's the marginal profit when n is equal to 20? Well, this is 18 minus 20 over 50 minus 7 times 20 to the power negative 0.3. So this answer to the question is 18 minus 20 over 50, 20 divided by 50, minus 7 times 20 to the power negative 0.3. So this is telling me my marginal profit here is $14.75. So if you're planning on selling 20 candles, and you're thinking, how much more money would I make if I sold 21 candles instead? Well, even after considering your costs, you'd be making an additional $14.75. And so this would just be the marginal revenue minus the marginal cost. So just double checking that. My marginal revenue for 20 candles was 19.6 minus the marginal cost at 20 candles, that was 4.85. So if you took 19.6 minus 4.85, hopefully we got the right answer there at 14.75. And man, we're getting so close. I just want to run the last scenario, which is what if we sell 500 candles? What is the total profit? So again, we just use our profit function, which is up here in green, for whenever n is equal to 500 instead. So the profit when n is 500 will be 18 times 500 minus n squared over 100. So minus 500 squared over 100 minus 90 minus 10 times 500 to the power 0.7. Okay, so let me just plug this in the calculator. Here we have 18 times 500 minus 500 to the power 2 divided by 100 minus 90 minus 10 times 500 to the power 0.7. So this is supposed to be $5,635. I'll just round to the nearest 10, so or the nearest dollar. So $56.35. And so this total profit, if we did this right, it should be the total revenue minus the total cost for 500 candles. So our total revenue for 500 candles was $7,500 minus the total cost for 500 candles, and the total cost was $1,865. So if we do 7,500 minus 1,865, 7,500 minus 1,865, hopefully we're careful, we should get 56.35, and that's exactly what we got. So our total profit checks out as revenue minus cost for that many candles. Okay, what would be the average profit for candle? So the average is going to be P bar, where the bar represents average, and this is just dividing by the number, our total profit by the number of candles. So that's 56.35 divided by 500. And so this should be the average cost, or sorry, the average revenue minus the average cost, if you want to check this out. But I'll just take the previous number here and divide by 500 to get our average profit per candle as $11.27. And the profit for selling one more candle would be our marginal revenue evaluated at 500. So our marginal revenue formula, that was 18 minus n over 50 minus 7 times n to to the power negative 0.3. So here we go, 18 minus 500 over 50 is just 10, minus 7 times 500 to the power negative 0.3. Let's see what we did wrong here. Negative 0.3. Does that help? Yeah, perfect. Okay. So this is 6.92. So your average profit per candle for selling 500 candles was $11.27. But if you just sold one more candle, your additional profit would only be $6.92. So it's still making more money, right? Because profit is revenue minus cost. So this is already after cost. So it's better to sell one more candle. But at some point, let's see what we have here. We see that profit is decreasing, right? From the average profit to the marginal profit. And so at some point, we're not going to be making more profit. So let's ask this question. If Amanda wants to maximize profit, and I think every business pretty much wants to maximize profit. Every business is sort of an optimization problem in mathematics of trying to see what decisions would maximize profit. What would be the ideal number of candles to produce and sell? So what N gives the maximum profit, which is capital P of N. That's our profit function. This is what we call in mathematics an optimization problem. And if you really want to, you can go in and, get your PhD in optimization if you want to, right? It's a very rich field of mathematics. And so this is actually a relatively easy optimization problem to solve. And in fact, we'll learn how to solve this optimization problem this semester. But there's a lot more to do in optimization, and it absolutely 100% applies to businesses directly. In fact, the field of industrial engineering is usually where most people go to study how to optimize or maximize profits for a business. But we're going to ask this question: what N gives the maximum profit? And we're going to first solve this just using Desmos.com. Okay, so let me pull that up real quick. Okay, so here in Desmos, what I've done is I went ahead and in red, this red curve that you see, I've plugged in our function for total profit. So on the horizontal axis, we have number of candles produced. And on the vertical axis, we have the amount of profit in dollars that you would gain. So this is revenue minus costs. And so at a certain point, you'll notice if I produce 0 candles, my profit is 0. Actually, if I produce 0 candles, my profit is negative 90, because if you go back and look at my cost function, I had a fixed cost of $90 built into there. So if I produce 0 candles after buying the hot plate for $90, right, and buying all the fixed equipment that I need, the utensils and whatnot, maybe the label maker. If I make 0 candles and I buy all the equipment, I'm down $90. If I sell 7, or actually 7.253 candles, so maybe I should say if I sell 8 candles, that's my break-even point. I go from losing money to making money if I sell 8 candles. And then if I want to sell a lot of candles, like if I want to sell more than 1,687 candles, then I'm actually going to be losing money again. And we might think about why that is, and it's a little bit complicated of an answer. But if you want to sell this many candles, what you would have to do to generate the demand, basically to generate enough interest among your audience, so enough interest among the people at the farmer's market, if you want them to buy more than this many candles, you would have to keep lowering your price. And if you have your price this low for selling each candle, it's going to generate a lot of demand, so people will buy this many candles, and yet the price is going to be lower than the cost of producing each candle. And so at that point, if you're selling your candles for less than it costs you to make them, then of course you're going to be losing more and more money with each candle that you sell, with each additional candle that you produce and sell. So one requisite for making money is that you price your product such that the price that you're selling it for is actually more than the cost of production. Right? That's the only way to make money. And then the last part, this is the part we're most interested in business, is this point where we maximize our profit. And so at a certain number of candles sold, we maximize our profit. And I don't know if you can read it. It's probably really small for you guys. But the X value here that gives the maximum profit is 854 candles. So 854 candles, that's the exact amount of candles you want to sell to make the most money. If you wanted to sell more than 854 candles, you would have to lower your price. And at that point, lowering your price, for the whole farmer's market is going to be more detrimental to your profits than the additional customers would be beneficial to your profits, right? So that would be the perfect number of candles to sell. It's 854 candles. Now, the next thing is what is the height of this profit? And that would be $6,862. And so if you priced your candles just perfectly to sell 854, you would earn in profit after revenues minus costs, your total profit, your net profit would be $6,862. And so that's the most money you can make given our demand curve that we came up with. And if you wanted price, like what's the ideal price to price your candles at? Remember, we had price as a function of number of candles sold. That was somewhere here. So price as a function of number of candles sold would be this. It would be 20 minus n over 100. 20 minus n over 100. So let's do that. 20 minus n over 100. So the ideal price for, let's see, 854 candles. Let's see where we end up on this green curve. The ideal price would be $11.46. So if you want to maximize your profits, first manufacture 854 candles and then show up to the farmer's market and price them, sell those candles at a price of $11.46. Okay? And one more thing I want to show you. If you didn't have Desmos.com to graph this, what would be a way that you could find what the maximum profit would be? Right? So if I couldn't just whip out this graphing calculator and punch in my profit curve and see where the maximum profit happens, how would I still find the number of candles that would give me the maximum profit? Well, notice that this red curve has some kind of steepness at each point, right? So it starts off very steep, and then it becomes less steep, and then it gets flat, and then it starts to point down, and then in the downward direction is less steep, and then it becomes more steep as the number of candles increases. But what's special about this point where the maximum is that it actually appears to be flat at that point. So I'm just zooming in for you to see, but at the point where the maximum profit is, if we zoom in far enough, it actually looks like a horizontal line. Now you may know that the slope of a horizontal line is 0. And you may also know that the derivative is just the slope of a tangent line at this point, at any given point along the curve. And so let's do a horizontal line at the point 6862, my maximum profit. And this line right here, I'll put it in green, I guess. This line is going to be tangent to my red curve at the point where the maximum profit is. So you know the slope of this tangent line is 0, and that gives me an intersection with my maximum profit. So what we found is that at the point where we have maximum profit, the derivative of the profit function is 0, and everywhere else, the derivative of the profit function is either positive, where the curve is increasing, or negative, where this curve is decreasing. And so what I could do as a way to find where my maximum profit is, I could set up an equation where my derivative of my profit function is equal to 0. First, I'm going to just graphically show to you that this works by adding a curve here. This blue curve down here, this is going to be the derivative of my profit function here in blue. And so where this derivative is equal to 0, that should be my maximum profit. And so again, I'm going to put that vertical line back in where my maximum profit happens. So at this purple line, that's the number of candles that gives me my maximum profit. What I want to show you is look at this blue curve representing the derivative. It's positive up until a certain point, and so it's slowly decreasing. And then where it's 0, that's my purple line. So my derivative of my function is 0, where I attain my maximum profit. And it's hard to see because they're kind of on different scales. But that blue curve becomes 0 at the same point of the maximum of the red curve, which is exactly what I'm telling you. The derivative of the profit function is 0 when we reach the maximum profit. Again, so if you did not have a graphing tool like Desmos.com available, and you were asked what value of the number of candles sold gives you the maximum profit, what we could do is say, well, let's talk about the derivative of my profit function. And I always forget what it is. 18 minus n over 50 minus 7 times n to the negative 0.3 power. I'm going to set this derivative equal to 0, and then this gives me one equation with one unknown value, right? I have one equation, and my unknown is n, the number of candles sold. That gives me the maximum profit. And so that actually, it might be difficult for you to solve for n yourself, but I wanted to point this out because we can numerically solve for n. And that's how it's going to be done in practice whenever you actually get into a business or engineering scenario. All right, thanks, and I'll see you in the next video.